Okay, guys.
Yeah. Okay. So I think there's a few directions we could go in today, depending on what people took from yesterday. I mean, if we want to recap, if people kind of understood it conceptually, everything from yesterday, then we could go straight into making some examples kind of from scratch, or we could go into more kind of advanced usage of schemas, or we can recap some concepts from yesterday, or I'm not sure what the best direction
is that how we would implement it or how we would get it.
For advanced usage, I would say I was going to show this example of like making a state machine controller, for example. So going beyond just parameterizing stuff, using it for experiment control as well. And then for the implementation, we could go and just do from scratch. Like here's actually setting up an experiment, for example, from scratch using the schema approach.
I think seeing the power of it would be nice.
Okay.
So maybe starting with that.
Okay.
We're probably motivated us to listen.
Okay. Okay. So I'll try and talk about the state machine thing a little bit. Yeah, so I'll start something completely new here. So if I'm doing some kind of vision experiment, which I haven't installed on Vision yet.
It's always 2.9 level.
Yes, this is.
But all of these things should be levels.
Yeah, it applies to everything else. Yeah, these should all apply to other stuff too. No, it's agnostic because it's just a code generation tool. So it's just taking a schema and turning it into C# classes. Okay, so I'm just setting up a super simple visual environment. So this is your kind of minimal drawer gratings kind of thing. Which should do exactly that. Okay, fine. Then often when you're actually doing an experiment, you want some kind of state machine that runs through different steps of your experiment. And the way this usually gets done in Bonsai is with these select many.
Yeah, Microsoft would say up there, I believe, but you have a definition of state machine that you, when you're thinking of what you mean by that, but I'm not sure that everyone shares the same.
I see. Okay. For me, I would just say maybe state machine is inappropriate, but some set of states that do something and a set of rules for how those states should transition between each other. So a state can be draw some gratings on screen, or it can be wait for a mouse to respond to something. And the set of transitions is, given what happens in that state, a timer elapses or a mouse licks something, which state do I go to next? That would be, yeah, that's maybe not the correct formal definition of it, but that's how I'm thinking of it.
But now we're speaking of states, it's, I guess it can apply to both the states within a trial as opposed to the kind of, for example, you could also imagine broader states of like training state,
Yeah.
1, stage 2, stage 3.
Yeah. Oh, yeah. Okay. Here I'm talking about it like the procession of things that happen during a trial. Yeah. Yeah, so the way you would do that in bonsai is basically by creating higher order observables. So in this case, select many. And I can kind of design what I want my trial to look like ahead of time. So I can say like inter-trial interval, example. So this is kind of a set of things that are going to happen, and then the requirement for each of these states defined by select many is that internally I have some logic for when it exits. So unit is just going to produce a value. I'm going to jump into intertrial interval, and it's going to start some kind of logic. And internally, I need to define when that state has ended. Like what's the when this observable should close and move to the next one. So in this case, it's super simple. I can just, from my source, I can just add a delay, like 2 seconds, let's say. And a take to close it. And then draw grading, so I can go in here and subscribe to my draw call. And I can do this for some amount of time as well. And then some key down to take the place of the mouse licking, for example. Take 2 looks, okay. Yeah, so this should wait for 2 seconds, draw some gratings, and then wait for me to lick twice, and then repeat the whole process. It doesn't. Oh. Repeat, just repeat it. It's because this doesn't. No, it should produce a value. Oops. Once again.
Bug it.
Yeah.
So if you want to have that, then we'll be able to leave any time after the sound into the site.
Yeah,
Mm-hmm.
yeah,
But now I have to wait for some of the sound.
Yeah. because in this case, the stimulus is a defined state. So,
Yeah, because it will just wait indefinitely in that state for the 2 loops. Okay, so that's yeah, that's the kind of basic setup of doing this kind of trial procession via states in bonsai. So there's a couple of things you'll you'll notice here is that all of the parameters for these states are hard-coded within the states themselves. So my delay has a hard-coded 2 here, and the amount of time that draw gratings is drawn for is hard-coded in here. And the number of licks that I want to wait for is also hard-coded. So you can, of course, parameterize these things. And to repeat a little bit what was talked about yesterday, just to cement it, the first way of doing that is I take those hard-coded parameters and I externalize them. Okay, so now at a slightly higher level, they're abstracted. So I can now click on each of these states and write them in myself in the property grid. And then I can go one level more and I can externalize them from the states themselves. Okay, now they all show up in the top level property grid. And then I can start doing things like defining them in subjects and things like that. So I can, I can literally write some variables at the start. So I can start populating them this way. So that's fine. And for a long time, this is how bonsai workflows operated, is that you would have a big list of variables in your property grid. That's how you define your experiment. You open your bonsai workflow and you go through this list and you say, here's what the parameters for my experiment are. The big disadvantage of that is that this bag of parameters that defines your experiment is very tightly coupled to the bonsai editor and to the workflow itself. And for lots of reasons, it's not necessarily the best approach. It's kind of hard to see in a different bit of software what your parameters are, unless you explicitly log them to a CSV or something, which is giving yourself twice the work, because not only have you written the state machine, you've written your parameters in here, you now need to think about, how do I log those parameters every time I run the experiment? So you're doubling your workload. It's also, it's on the other hand of just defining them in the first place, like this can get very large very quickly and quite cumbersome. And okay, you can like go in here and you can start giving them display names, like and you can categorize them. You can start making this look a little bit nicer, but again, it's kind of double the work, and it's work that you end up doing in lots of different places. You end up doing it here, you end up doing it in your logging, and you also end up doing it in your analysis.
Is that just a break, just to interrupt with that. There's a couple of other things that like this means you can't do as well, like with doing it this way. Like if you have bonsai workflows or scripts that are calling other workflows from command line, for example, and then yes, you can pass the parameters in a really long one-liner, but because it's tied into the editor, if you're running stuff that's running like from a command line, you're better off having, because then you've got to check all your parameters are correct within your one line, and you've got no log of that, except as Andrew's saying, unless you log it explicitly within the workflow. But you just don't have as much control. Workflows talking to other workflows and other calls, as well.
Okay. The other thing to note that I'll get to as well is not only were those parameters hard-coded, but the procession of the state machine itself is hard coded, right? And if I come back and I want to change the experiment slightly, or I want to add a new state, I have to go back into my workflow and physically add a new thing at the end here. Sorry. And then if I want to change the order of things, I need to like move around where this goes, and then you end up as different people that try different experiments, you end up with this big tree of different workflows where people are trying different ways of processing through their experiment. So there's two things we want to parameterize here. One is just these individual values or variables that describe the properties of each state. And the second is the state machine itself, which is a slightly higher order way of thinking about it. So we've got until 11, right? Okay. So I think I can do both. So the first thing I'll do is kind of recap what we talked about yesterday and just make a quick schema to parameterize this experiment, and then I'll talk about defining the state machine itself in a schema. So looking at what I need to do here, I've got these three parameters: the intertrial interval, the period that the draw gratings gets drawn over, and the number of licks that I care about. And if I'm in my kind of bonsai workflow here, I'm going to first define my schema for talking about these things. Let's call it like experiment schema.
Start coding the copy paste.
Mm-hmm.
Or start coding the copy paste.
So my kind of totally minimal definition schema looks like this. I give it some ID, some title, type, which is just the generic object, and the what would you call this? Like the protocol for the schema, I guess. So this is just
protocol for the schema is something that we should be concerned about.
I
Be very specific.
I think it will pretty much always be the same thing.
The draft 4 or draft 7.
Yeah.
What we've used. It works with others, but
Yeah,
not.
and it's like syntax definition basically. So it's
That's the fixing and should just think about 7.
Yeah.
something like that.
so I have so now I want to define some properties that I care about. So I'll do intertrial interval. And there's lots of things you can specify here, but let's just write these out first. So we had intertrial interval, stimulus duration, and end licks. Okay. All of these, I think, by default need a numerical type. And what you have is, or rather a data type. So you can have array, Boolean, integer, null, number, object, string. Number in this case covers anything that's not an integer. So anything with a floating or double precision. Yeah. I think these get by default converted to double precision in bonsai. So this will also be a type of number. And this will be type integer. You can also do some fancy stuff here. So you maybe want to put some restrictions on the people who are writing these schemas or give them some warnings. So I can also say, for example, this has to be at least 1 second. Maybe maximum 5 seconds. Similar thing here. 1. And I probably want this to be minimum 1 as well. And this you can do lots of fancy things with this. Like, for example, if I have some, I don't know, like angle, like let's say, for example, I wanted to randomize the angle of the grating. I could say like angle range I could say this is has items of type number. They must be between 0 and 360. And because I want this to be a min-max thing, and say I want the min items in this array to be 2, and the max items to be 2. Yeah, right, that's right. True. Yes. So, and then you can also stick descriptions in here. So it will actually, what will happen in this case is it will, you could force it to not have 2. When you come to define it, it will complain at you, but it won't error out until you hit bonsai. So as you'll see in a sec, the YAML file that I'm using to implement this will put a little reg squiggly line and say you're not allowed to do that. But there's nothing stopping me because it's just a text file from still loading it into bonsai and bonsai crashing. But actually where bonsai will crash is if the bonsai implementation is looking for the min range and the max range and I haven't put anything in, or I've only put one thing in, it'll get an index error. Otherwise it will quite happily, if I put 5 in, bonsai will still quite happily look for the 0 in the first one. So it'll be run.
Finding like a list of trials, and after trial 100, twice the question makes one, and then it fails.
Yeah, that's what it's doing. Yeah.
In projects where I've implemented this so far anyway, but usually put a little check in, just run through the things that the experiments, and you don't have trials.
When you say don't do things in type your dummy one without taking the entire time of the experiment.
Yeah, essentially. So another thing you can do, for example, is build like static dictionaries in Schema, but because you're not validating the actual values of everything until you come to runtime and run through it. Yeah, so you can it would be a similar sort of thing if you had a CSV and just run through all the rows and just check all the values exist and that they're within a range, and before you actually start the experiment, it takes like half a second to run through it. So sometimes that's good to do.
Yeah.
But I guess that's a manual thing that you have to program. You can't just say validate schema and throw an error if that doesn't match.
Well, so as Andrew says, when you actually specify when you populate these classes with values that you can specify in the YAML, then YAML will give you warnings. Yeah, so there's one check.
Yeah. So yeah, we can make so this you can think of as the kind of abstract definition of what data is needed to define your experiment. And Gonzalo showed an example yesterday where he was using Pydantic to make more concrete implementations for an experiment. In this case, I'm going to use just another text file, a YAML file, that's kind of context aware of this definition. So I'll just call this like experiment 1.yaml. And I need to tell it which schema it should care about.
The YAML extension of VS Code is to work.
Oh yeah. Yeah, there's a couple of extensions that allow VS Code to do this context aware thing. And then what parameters did I have again? Into trial interval.
The VS Code, you can use any other as long as it has YAML that, or is it?
Yeah, you can. We use VS Code, but it's just a text file.
Is my other one. Index.
Yes, you can see ChatGPT. Everyone loves to use it. Copilot's not bad at this either, actually. I discovered the other day.
Oh no, is it?
Yeah. It gets better and better. I was coding on a machine at SWC because they have it installed on some of the experimental machines.
Yeah.
It comes, I think UCL have that. Do Copilot? You can get Copilot with UCL now, right? And yeah, as your code, at first it's really annoying. Just like, stop trying to help me. Just let me type the thing I want to type. And then after a while, it's like it's suggesting things and like, oh yeah, do that and that. Yep, and that.
By that thing.
Yeah, exactly, yeah.
I don't like it.
No, I don't like it. It's like,
Butlerian jihad, in my opinion.
sorry.
Butlerian jihad, in my okay, so I've put the parameters that I'm supposed to have. The YAML's complaining at me because this is below my minimum value. Same thing here. NLEX also has a minimum. And this is complaining.
Only got one item.
Only got one item, so I stick this in here. For whatever reason, I want it to be that.
The items are implementing. That would be a limit.
I don't think you can check. I don't think you can check that it's incrementing. You could do it in a kind of round. Actually, I'm not sure if this is true. I was going to say you could do it in a roundabout way by defining a minimum angle property and a maximum angle property, and saying that the minimum references the other property. I'm actually not sure if you can do that.
That would work either.
No.
So did you have to run something, or was it just automatically giving you the errors?
This was yeah, it's pointing at the schema.
Yeah.
So it's kind of aware of these restrictions that I put on.
So while you were typing, you already will get it was checking it.
Yeah. You do need some extensions to do that. Checking lists.
It's just the red hat gallery.
Yeah, it's there's like this JSON one, and
Is this just website?
I don't think it is actually. I've got it listed on other projects, but I can put a listing for it.
And
Yeah, but it's basically what you expect it to be. It's YAML and JSON, like the most popular YAML and JSON extensions on Visual
I
Studio
think it
Code.
might prompt you as well when you start writing in YAML. It might tell you, do you want to install this extension? It's supposed quite big of that.
Yeah.
But yeah, we should put it somewhere for sure. That's good.
So I have now in abstract what data my experiment expects to define itself. I have a concrete implementation for experiment 1. We also need to use SGEN again to convert this into something Bonsai understands, so that it has access to the data classes. No copilot, go away.
Which was waiting beyond the trial, that is.
Yeah.
So for example, here you've got something that the trial needs for the raise, for example, with fixed number. Could you vary that to be the better, like a list of numbers in this case, and put that in as an array, and then have
Yes,
that sequence actually understand?
you could. Yeah, you could have. Yeah, you could put it in as an array, and then you could, for example, just load that array at the start of the experiment and permute it, and then, or you could sample from the array. You can do whatever you like. Really, basically, where you're limited is the JSON schema for the most part doesn't let you do much fancy logic like sampling and things like that. It allows you to set minimums and maximums and place some other restrictions on it, but it's ultimately just a data representation. Anything like how you choose to permute it or sample it is going to end up being in Bonsai for the most part.
And put an array of 100 numbers in, for example.
Yeah.
And say,
Yeah, you can put like, definite numbers, or I think usually practically what I end up doing is finding some way of, if you've got 100 numbers, you represent it with some, like 2 parameters that multiply or something like that. Yeah.
sometimes it's like machine the direct inspected on the pair thing also. That's
I think it is. And I'll get there. I'll do a super simple state machine, and then I'll show a way of making it more generic and potentially even more past that. At some point, there's this like balance, right? Because you'll see that at some point your YAML state machine definition gets so complex that you're writing a new language and a new compiler. And so there's some balance where it's like, I don't want to do that. I just want to tell Bonsai how to process, but
install SGEN in this folder.
Oh yeah. I got my global one, yeah. So same process as you saw yesterday. So I have my schema, I run SGEN to generate that into the auto-generated clusters and stick that in my extensions folder for Bonsai. I reload Bonsai now. I should have access to the experiment class. So I can do it this way. I can, create an experiment class, set a load of properties in it, and then feed that into my externalized properties. Or I think the nicer way is just to read that YAML file that had my experiment definition. And deserialize. Yes. So yeah, this relates to a question that I think was asked yesterday about how you can split your schemas up. Yes, so every time you generate, because I have two schemas in this folder, I've got the rule schema that I'll show for the state machine I haven't talked about yet, and I've got the data schema that I just implemented. I can choose from each of these. So let's just double check this works. So now instead of a whole list of parameters that I can set in the property grid, I have one, which is a path to my experiment definition. Running this on its own will give me the class that has the particular parameters for this experiment. And then it's the extra work you have to do is defining how these gets implemented. So my intertrial interval, which needs to be as a time span. That was probably the other thing that was going wrong.
Just to point out, even this, although that's a little bit of extra work, if you now change the schema, in the past, if you were doing all of this with expression transforms and named variables in a dynamic class, then if you change it, then the order of the tuple changes. So you have to redo all of this, all of the expression transform and rename it and redefine the class. But if you update the schema now, these names don't change, right? So you don't have to rehash the workflow after.
So exactly. So now if I want to do a second experiment, cool. Now it's just a case of changing this once. and so on. Okay, so the nice thing about this is, in this kind of toy example, everyone works off one workflow. The experiment is just defined by one workflow. What you change and share between people and between labs are these files. So you just pass these files around, and this defines an experiment. Okay, so this is an example of actually parameterizing using the schema method. We can talk about the state machine stuff here. So yeah, as I said before, we've got this hard-coded in a sense state machine in that it's defined in the work.
Define which ones I work with, the schema belongs to.
No, it's agnostic. So yeah, because all it is a data representation, and it's just represented as a text file. The file doesn't care what workflow it's.
Is it possible to put it on that? Even as a promise?
So
What do you mean, sir?
Like if I'm passing that around,
mhm.
like it's important to know what the brain runs.
I see.
It's compatible.
You could, I mean, you could do this by, for example, like one of your properties could be,
Workflow.
yeah. You could even be like allowed workflows.
Oops, sorry.
Well, so the code that's also generated in C#, you put that in your extensions folder, and your extensions folder are usually with your workflows. So only the workflows within that folder with that will look in that extensions folder. So if you were writing a C# transform or your own bonsai operator or whatever, you put it in those extensions and it would live with the workflow. In that
What I was wondering, like, if you're running an experiment on a given day, you could have like version of that goes into further. Like currently you can say the whole work. I guess the idea here is to say the schema.
Yeah.
But if you see it's just a YAML file,
Yeah.
that doesn't have info which workflow, which version of one.
Agreed.
That. So you won't be able to replicate the experiment.
Yes.
Without that info.
You do have a kind of soft lock though, because the bonsai workflow has to have the generated C# classes for that schema. For the deserialization. So when you run bonsai and try and load that file in and deserialize it, if it hasn't been given those generated classes from the JSON, it will complain. It won't tell you like this file is not allowed to be associated with this. It will just say, I don't know how to read this file.
Okay, another way to do it, because no manual together.
Yeah, so that one way that's totally legitimate way of doing it. One way that I would push a little bit is that we do with we have some big projects where like many different experiments are happening on different branches and from different versions of the code and the rest of it. I think Project Down and different people and different rigs and all the rest of it. And the data for that is always logged with the commit hash of the repo as in its state at the time. This is a little bit like not really related to the SGEN stuff. It's just another way of doing it. And actually we have a restriction on Project Down, for example, that the version of the workflow and the code, well, the whole repo, in fact, has to also be tagged and be clean. So we do a check that like no one's made any changes to the code. So then you store and you log the data with that commit hash. There's no way you can, or with that tag, there's no way you can always, no matter what happens to the GitHub or anything, you can always recover exactly the code that was run.
This would be for the workflow, but only for the YAML.
Well, the YAML you can also store with the repo, right? So it's stored in the same state. So that might be another way of that you might want to consider keeping track of that. I think
Isn't there even more restrictions on the Eon that it's like if it detects it's not in the main branch of Git, it behaves differently.
Yeah.
So if someone's doing something in a development branch on Git, it won't like log and run the experiment in the same way, or it'll at least log the data. It's something like it logs the data, but it says, "Hey, this data comes from like a not a verified main branch of Git. It's like maybe something someone was doing for testing or
It puts it
something.
in a different named folder. It won't log it
Yeah.
in the same format, and it won't upload it to the cloud. And because of course we can do it. We can do all of these things, right?
Yeah.
We can log all the metadata and so on. So yeah.
Another question, so you importing the single parameters. So something like build grading stands like another package of bulk parameters.
Yeah.
Mm-hmm.
You don't really want to be drawing all the externalized properties for each of those independent parameters if you avoid it.
Yeah.
Can you just pipe through the parameters that you are changing through to the full
Yeah.
bulk gradings, and then just managing the ones that you're actually changing?
I think at some point you do end up having to do something manually. But the one thing you can do is instead of externalized property, you can use an input mapping, which allows you to do, you still have to do something manually, but basically you get a selector and a type mapping. So the selector is the thing that comes from here that initiates this. And then if you double click on this, it allows you to add all the type mappings that you want to do. So that allows you to do this where you would normally have lots and lots of externalized properties. You condense it all into one input mapping.
It's not too much work because you can also add all the properties in one click from external.
Oh, yeah.
Input mapping.
Yeah. And then once it's done, you can also copy and paste it across to everywhere else that you draw gratings. Everywhere that you have like experiment being mapped to draw gratings, you just copy and paste it. Yeah. Okay, so I'll move on to the other example here, which is my state machine. So this is another kind of toy example, but hopefully you can see how this can be built upon quite a lot. So if I run this, all it does is tells me the experiment started, and I give it some initiating event, which is a key press, and it'll start moving through some states. And it'll keep looping through all these. So in fact, in here, there is no state machine defined in the way that I said before. There's no set of nodes physically connected to each other. The first clue about how this works is in the state definitions. So I have, instead of states connected to each other, I just have like a bag of potential states. And they're grouped by their type. So simple state is, all the states have a parameter, which is their name. But simple state has an additional property, which is the message that it wants to send. And you can have any logic you want in here, but for this simple case, it has a parameter of a string that it is going to try and output. So each of these
like a function name.
yeah, it could be a function name. It could be a big bag of parameters that define draw gratings. It can be sort of anything you like, really.
These states, so my question,
Yeah.
question, are these states are these structured like a select menu, or are they create observables? Or?
They are create observables because you don't want to subscribe to these straight away.
Yeah.
So they go in here. Sorry, not that one.
It's 2.9.
Yeah. So the requirement for a state is that it has a create observable and a string. So it's its name, and then it's the actual logic that it does. And then in here, all it does is send a string to the state message subject, and then it waits for some time. But in here, it can be anything you want. In the current setup, the only requirement is that it outputs a Boolean, true or false. And so what you end up with is a whole dictionary of states. I create to a dictionary here, where basically you have a name, you have a key lookup, and then you have some observable logic.
The wait period.
Yeah. And you can get very granular with this. You can have a state that's called draw gratings, and you can have a state that's called wait for X time, or wait for key press, all this kind of stuff. So you have this bag of named states here, essentially. And then in the JSON schema, what I have is, it's very simple. Again, you have some properties, which you have a rule alias, which is just the name of the current state machine or the rule. And then you have a set of state definitions. You have an array of state definitions. State definition is just defined by the name of that state and the state that it transitions to. And if I just show you a kind of demo rule here, the requirement in the way I've set it up here is that you have a default state. So this is the state that you go to if there's no transition available. And it's also the beginning state of the whole thing. And then you have some circular logic for how you progress through. So state A goes to B, B goes to C, C goes to D, D goes to A. So keeping in mind that these states can do anything you want, this is quite a powerful way of defining an entire experiment and the order of how things happen just in a YAML file. And you can have one single bonsai workflow that just has the set of available states, and then you can write the entire procession of your trials just in a text file like this.
If you want to conditionalize the so if condition 1 is met, you have to say that condition 2 is met, you have to say C.
Yeah. So I'll show you a demo of that. That's not complete yet, but will be soon. I'll show you what it looks like in theory, and then so this is something that does what you're talking about, and if I add a little bit to it, let's see how that works. So one nice thing that you can do in the schemas is that you can say, oh yes, there's this one-of keyword in JSON that allows you to have a state definition now that instead of having a single data type as a property, it can have multiple different types with different class definitions. So in C#, this would just be a generic object that you can then cast to something specific. But I can say, okay, the state definition has a visual stimulus, and it's going to be one of gratings or checkerboard, each of which has a different set of parameters. And then it also has a transitions on definition, which is like a logic state that's like a timer or a wait for key. And these in turn have their own parameter sets. So wait key has a key that it's waiting for. So in this particular case, for this one, it only has a single transition, but you can imagine a case where I have, instead of a transitions on and a transitions to, I just have a bag of transitions as well as a bag of states. Like so.
Like
Hmm?
you time. Like,
Okay. So that, yeah, the next level up, as you can imagine, defining it like this. So for any state,
Like a list of allowed transitions.
yes,
of the original.
it's for the state you're in, you have a set of possible transitions out of that state and which state they go to if the conditions are met. So if you're in the grating state, in the actual state machine controller in Bonsai, once you reach that state, it goes and looks up in a separate dictionary. It has like a state dictionary and a transition dictionary. And it goes and subscribes to all the observables that describe how you wait for a key and how you wait for a timer. The first one of those observables that produces a result will also tell you, based on that result, which state I should go to next.
When they find out and go back to grading, you can have a key person up for the checkboard, for example.
Yeah, exactly. And once you've got that in place, you can. So yeah, there's two components. You have to name the state and the transitions, and then you have to define what that named state does in Bonsai. And you can get very, these are simple ones where it is a timer with some due time parameter or a wait key. you can also do things like you can start doing conditional probabilities by having a state that when it like a transition logic state that when it goes in, it creates some random distribution, and you give it a bag of state names, and it goes depending on what you sample from that distribution, you go to one or more of the states. Because the end requirement is just that you have a state that does something, and then a transition state that gets called. The transition state just has to spit out a string, which is the next state to go to. And internally, you can do whatever you want inside that state to produce the string. Yeah. So yeah, the state in the initialization, I'm doing a few things here. So rather than doing read all text, I have a custom class here called the rule selector. This is basically doing the same thing, but it is a custom bonsai operator that every time I load a file, it updates this subject. So I can change the rules in the middle of the experiment. And I can also do this while the experiment's running. So for example, I can say, I can start this going, and I can start my state machine running. And then while the experiment's running, I'm like, actually, I want to do something slightly different. I haven't tested this, so it might not work. But I think it will. So now I'll say, okay, I want state A to go to state C to go to state B to go to state B, C, B, B to D, and then D to go back to A. Yeah. So now I've got a second rule here that behaves slightly differently. And while this is running, I can just jump in my rule selector, change the rule. And now it changes the, yeah.
This is not the recommended way of running the experiment.
No, it's not.
Definitely.
But it is nice. Yeah. But it's nice for, I think it's nice for debugging stuff, potentially. I mean, yeah, this is maybe a bit too fancy for its own good, but it's nice if you want to, instead of starting and restarting, you just want to have something running and like do new parameters on the fly and so on. It's kind of nice. It's more just to show what's possible with.
I guess we realize the animals here as well.
Yes.
So there's
Exactly.
something starting to experiment.
Yeah.
Just to clarify, in this information is that people used to do, because people would use the video one to define the state and tricks in that.
Yeah, yeah. Yeah, I think I've used Beepod. Yeah, you have this kind of like state machine language in Beepod, right? That's yeah. So I guess yeah, this is kind of an attempt to do something similar, but more generic in the sense that it's not tied to any kind of hardware. Yeah.
I'm guessing this can go over that.
Yes, it can. Yeah. We have an example of that somewhere, I think.
But then the YAML that you show is something that you know.
Yes.
If you updated the YAML with the same file, is that going to get updated?
If you change, so if you had your workflow running and you change the file, it wouldn't do anything until you explicitly loaded it again in Bonsai. Because you've broken the reference to the file because you've created your C# class from it, which is now in memory. Yeah.
No, but if you're doing everything in like, if you just, you've got a server sending something rather than working on the web.
Bonsai doesn't know the file changed, just knows when it's asked to load in, to load the YAML. It doesn't know on its own when, if you change the thing and say that it doesn't know, it doesn't fall to Windows, it knows it got saved. Yeah, yeah.
There's a question I have because I wonder, it's like can't change random numbers, for instance, on the fly as it goes. to the states of one trial that we initiate a new trial, we have to pre-specify, I think this is right, we're going to try to interview. We have to pre-specify them in the beginning and then load them entirely vector or anything that on the plan. The solution state machines can be identified. Each
Yeah.
trial goes to this state transition matrix, there are three, and then you can generate a new random number and just line through the matrix. But
But your states inside one sort of create observables that like the individual states that Andrew was showing. You can, as I said, you can do whatever you want in there. So if you want a random, if you want to plot, if you want to make a distribution from parameters that you've got in your schema and take a random from that, or have a random time selected, yeah, you can do all of that, no problem.
I guess the actual generation of randomness is done at the bonsai.
In this case, yes, yeah.
But quickly we do it in C#. That's how we are doing it at the moment. We're defining the distribution and the range of values, and then as we're initializing a file, we draw that value.
Right, but the actual draw is happening.
That's C#. And then bonsai only sees that's the random power for this file.
Oh yeah, regarding the network stuff, because these are just text files, they're relatively lightweight text files as well. You can send all this through a network. It's an example of this here, which is, so I have a, this is all on my same machine, so it's cheating, but I have a server workflow and a client workflow. The job of the client workflow is just to read a load of files and store different parameter files. So it's reading through these three parameter YAML files that I have here, which are just doing gratings, definition stuff. And then they set up a little endpoint that a client can poll and ask for parameter files basically from the server. So this guy will just sit here and run on its own, enumerates through the files and deserializes them. But actually it just sends the regular file back through. On the client side, the client just polls the server, so it sends a little request and says what parameter files do you have available for me, and populates a little list box, and then from there I can switch through and change the parameters of how I'm drawing.
So it's potentially was that as I understand it correctly, Aman's earlier question where you could have that you could have the workflow saying this is the workflow I am.
Yeah.
What parameters do you have available? And then you could provide just a list of the specific files that match that work.
Yeah, that's all possible. Yeah.
That's the idea, I think.
Yeah.
The only kind of idea I
Very next case, the bonsai file is no, which might be on the
it could work if again understanding correctly, but the server could load these files within which the files say these are the workflows that I am compatible with. And then when you query the server, you say I am this workflow, please provide all the compatible files you have that I can use.
You just, and on top of that, you could do what Tom was saying, is you could also say, yes, I have these files, but they're only available to these workflows, and they're only available to these workflows past commit number, whatever on Git, or only if they're on the main side. Yeah.
The validation you were talking about before, that could actually have the bonsai test on the piano, if it could just work, it could just validate it.
Yeah.
If you had
And
a,
if it didn't work, it would just say do that.
if you had like, if all your schemas had a common high level like workflow list of names, then all the rest can be whatever, and it doesn't need to, as long as it can deserialize the top level name of the workflow. You could potentially have many different schemas with all kinds of different stuff on them. But they all have the same parameter name, the workflow of the list of workflows it is compatible with, then you can query any schema across all your workflows.
But I think what you were saying before, that actually could have bonsai generate
Yes,
because it could try to validate the workflow and if it doesn't succeed.
yeah.
So it took a half second for it to, or whatever this functional workflow,
Yeah,
but it would actually be able to check the other active one.
yes.
And then you run the list of points about
Yes, actually you could do that. Yeah, why not? Yeah, why not?
think there are two ways to approach this. One is that each YAML file could specify I'm a DOM or I'm in a field workflow, and this is what I'm compatible with. Or you could have Bonsai actually go through the YAML and check for certain parameters that you would need from the YAML. Yes, which one would be preferable?
But the second one, Bonsai goes through and checks which, so you would
It
rather
goes
have,
through the parameters and sees if it matches the type names that you're passing.
oh yeah, okay.
You would do that for every file in the directory.
Yeah, and any that failed, just have some condition loop to just, yeah.
Yeah.
What's that
Well,
thing?
no, the brainstorming.
This is what, like-
extension to it.
It's what like GraphQL or something does, isn't it? It's kind of like what you're saying there with the second option is you're rather asking for what you need.
Yeah.
Rather than being given. Yeah, it's like the two things. Is either the workflow asks for what it needs from a thing, or on the other hand, the server tells you what you should need, and if you say, well, I don't need that one, then it says you're not compatible then.
Yeah.
Yeah.
I mean, these discussions will continue, of course, with the time.